Hello, everyone. Welcome back, and thank you for showing up for your learning in a continuous way. Learning is something that happens periodically as well, so you can model the amount of time you spend in class over the day or over the year, and it would have some periodic function. Anyway, I hope you have seen the lesson on special triangles in the unit circle. Hyperlink coming as my upload completes. But then watch this video from Numberphile. It's a beautiful video about trigonometry and the different ways to visualize these functions. Right now, you are going to graph sine x and cos x by hand. So that's great. So you've already done this in Desmos and you've already investigated this in Desmos, but doing it by hand is going to reinforce your learning. And then you'll have this paper copy that you can use to then transform the trigonometric functions by transforming parent functions later. All right, let's get started, everybody. So we've already filled in our unit circle, and we're going to be using this as we go to graph our parent trig functions. So here, let's start with sine x. So I will do sine x in blue because I like blue. So this is f of x is equal to sine x. Okay, so what this is saying is it's a set of instructions. It says take a number x and then take the sine of that number as though it was an angle. Okay, it's not always going to be an angle, but it's how this works. So now we recall that the sine of 0 is 0, so we can plot that there. I can go over here to my unit circle and see 0 over there. I'm actually going to take all the zeros. So here is one value of sine that's 0, and here's another one at 180. So I'm going to put both of those on, and I'm going to draw them in big black points, just to connect to the drawing that we have of the unit circle. So there is 1 point, that's 0, and then 180 was also 0, and then 360 was also a 0, okay? And I have a unit circle down here that I can use to remind myself. So I'm just going to draw on my unit circle there. This is 360 degrees, like that. And the value of sine is given there as 0, okay? So that's where I'm getting that, okay? And so there, we've got all the zeros down. Cool. So now let's go over to our unit circle and let's grab the 45s. The 45, the 135, and the 225. So we're going to use orange for these points. Okay. And I have this one here. This is happening just between 90 and 180. So this one is happening at 135. So I can draw that on the unit circle there just to remind myself. Oh, I need to change the color in all of my tabs. Okay. So this is 135 here. 135 degrees. And the value there, well, that would be negative 1 over root 2 and 1 over root 2, okay, for that point there. And we get that from the unit circle. So at 45 degrees, or here, that's 1 over root 2. Here's a half. 1 over root 2 is about like 0.7. So here's 0.75, so let's put there. Boom, just plot that on. Put a nice big point. And if you're wondering, well, how would I do that, Mr. Jennings? Like, how do I plot that on this XY graph? Well, let's put our scale on here first. You can put the scale on in black or blue or whatever you like. Here, this is 1. This is negative 1. This is 0.5. This is negative 0.5. It's negative a half. Okay, so that's our scale in decimal form. I'll do the one down there in fractions because I prefer fractions anyway. So if you go to a calculator, it's going to tell you these things. So let's take a look at that. Your calculator just tell you 1 divided by the square root of 2 square root equals 0.7. Yeah, so very close to 0.71. So below 0.75. So that's that point there. Okay, so we got the 45 on. We can put on this one. It's going to be negative because we see the value of sine there comes from this x value. Sorry, there's the y value here. So it's also positive. Yeah, of course it's positive. And then so that's going to be over there. The value of sine Remember, I have this XY inversion sort of. I'm not labeled dyslexic, but I often invert my X's and y Y's. The value of sine comes from the Y over here. So it's 1 over root 2. It's still positive. But then down here, for 225, it's going to be negative. So it's going to be just a little bit above here. And then 315, it's going to be the same. It's down here. And those come from these values in the unit circle down here. This one, 225, and this one, 315. Okay, let's keep going. Now we are going to put on our 30 degrees, and we did those in blue. So we're going to still continue that in blue. So for 30 degrees, that's here. 90, 60, 30, okay? So this is 30 degrees. That's exactly at 1/2. And then 90 plus 180 minus 30, that's also here. So that's 150. So we got those from the unit circle. 150, that's 1/2. And 30, that's 1/2. Now, these two are negative. There, 1/2, and there, 1/2. Okay, cool. And then we also can do, well, let's do these ones, the 90 and the 270. There's no reason not to put those on. Put those on in black. So let's go for it. Boom, black. Pew. So 90 was 1. That's way up there. And 270 was 1. It's way down here. And now it's very clear this one's a mistake. Why? Well, I make mistakes. Everyone does. Here we go. Growth mindset, everybody. This one here, 330 is there. And if I'm using my unit circle carefully, some of you are probably yelling at your screen saying, Mr. Jennings, get that correct. There it is right there. That's the value of sine that we want, 330. Okay, so now this is starting to look like a beautiful curve. Last ones that we're going to do are our 60 degrees in green. And so this is 60 degrees here. That's root 3 over 2. Root 3 over 2. This is one of the annoying calculators that I need to type 3. This is the square root of 3. I'm going to divide that by 2. That is equal to 0.866. So bigger than 0.75. This is bigger than 3/4. Okay, so here's 0.75. This is going to be bigger. We're already in green, so we're just going to put that in there at 0.866. It's right there. And then this one over here, that's 180 minus 60. That's 120. And then down here, this is 180 plus 60. That's 240. And then this is 360 minus 60. That's 300. All right, now we can go ahead and put our beautiful sine curve through all of this. And you're like, yeah, I'll believe it when I see it, Mr. Jennings, if you can actually hit points with this technology. Yeah, okay, so there's a sine curve. Parent function. We can connect these to the unit circle here as well. So like, and this is also going to help us just quickly do our cosine curve. So this one here, this is 180 plus, that's 240. So 240 is down here. And that's giving us this value of sine, which is, based on this triangle here, and this x value, which, sorry, this y value here, which is negative root 3 over 2. Negative root 3 over 2. And we're going to use that also for the cosine, which is negative 1/2. Okay, and then this one here was our 30 degrees. So let's get that on as well, just so you can see on your handout this connection between these things. This is root 3 over 2, and this is 1/2. So of course the 1/2 is sine because that's opposite, and that goes there. And then the root 3 over 2 is going to come down for cosine. Let's go do cosine. It's going to be much faster, everybody. All right, so cosine, 0. Well, let's put on all of our black marks this time. So we have cosine starts at 1 at 0, goes down to 0, goes down to -1 at 180, and then is back to 0 at 270. Okay, so let's put on those. We'll use black. So here, starts at 1. It had it went down to 0 at 180, at 0 at 90, and then went down to its -1 at 180, went up to 0 at 270, and then it's back to 1 at 360. So that gives us our basic outline. It's going to go like that. Okay, it's the same curve as this, just shifted over. It's as though I drew the y-axis right there, and it goes down and comes back up again. Oh, be very careful, Mr. J. There we go. Okay, so now we've got all those black points on. Let's get our 45 degrees. So they're here. And I already have this one handy. So that cosine comes from this here. So that's -1 over root 2. And we recall that this happens, well, this is 135. So it's right in between 90 and 180. And it's -1 over root 2. It's a little bit less than that. So a little bit less than 0.75. So about there. Definitely bigger than a half. And then there's a symmetrical point over here. And the positive ones we get at 45. And 315. All right. Makes me want to go to the gym. If you get that reference, let me know what I'm talking about. 45, 135, 225, 315. You know this? If you do, you're pretty strong. Okay. All right. Not strong mathematically necessarily, strong muscle-wise. Okay, now let's do our 30 degrees. So here is cosine is given by the x value, so root 3 over 2. So this one at 30 is root 3 over 2, which is 0.866. Remember, this is 1, this is 1/2, this is 0, this is -1/2, and this is -1. Okay, so we're pretty zoomed in here in terms of the y values. So that's there. And then we have another 30 degree that happens over here. This is 180 minus 30. So that's a -1. That's there. And then 180 plus 30. And then we have 300 minus 30 over here. So there's all of our blue points, okay, that we got from the unit circle. Okay, don't. They know it, Mr. Jennings. Just do it. Now, last ones are the 60 degrees. So 60 is there 1/2. Cosine 60 is 1/2. And then 180 minus 60 is there. So it's -1/2. 180 plus 60 is there. So that's -1/2. And then 360 minus 60 is there. +1/2. Now we're ready to trace our curve through all of that. A beautiful cosine curve. We could call it g of x equals cosine of x. And so it goes through here. It helps to bite your tongue. Hit your points. Okay, there we go. We've graphed by hand sine and cosine. Very good, everyone. So these are our parent functions. You want to have a very clear idea of these parent functions so that you can transform them into various trig functions that can model real-world things that go on. All right, everyone. See you in the next lesson. Thank you very much for showing up for your learning. Hit me up by email or in the chat with all of your questions.